Hello everyone, my name is Shihan from Duke University. Today I will present our work on user password exposure to third-party CDNs. This is a joint work by my collaborator Rizin and my advisor Professor Xiaowei at Duke University. Nowadays, third-party content delivery networks are very popular, such as Akamai, Cloudflare, and Fastly. Websites use CDNs to speed up web page retrieval. As the picture shows, the CDN cache the web content at the edge server near clients. However, as mentioned in the prior work, CDNs can observe the traffic between the clients and the origin server because of the HTTPS termination. Here is an example of the consequence of such HTTPS termination. We capture the login request when the user wants to log into the Reddit website. We can find that the request payload contains the plaintext password and the request is sent to an IP address. However, if we check the information of this IP address, it actually belongs to Fastly instead of Reddit. It means that the login request is sent to the Fastly when user try to log in to the Reddit. So the Fastly actually observe user's passwords when a user try to log in to the Reddit website. So this is the password exposure to third-party CDN. And there are two countermeasures in practice. One is CDN bypassing, another is a client-side encryption. For CDN bypassing, the client bypass CDN and send the login request to the origin server directly. And in the client-side encryption, the client will encrypt the password in the login request and send the login request to the CDN. The CDN forward the login request with the encrypted password to the origin server. However, these two solutions has its own limitation. For CDN bypassing, it exposes the origin server to the public, leading to DDoS attacks. For client-side encryption, it can only prevent a passive attacker, but it cannot prevent an active attacker who will tamper with the message. Despite the limitation, the client-side encryption is still a preliminary defense of the password exposure. So in this work, we aim to answer two questions. The first one is how many websites expose user password to third-party CDNs? The second one is how many websites adopt the client-side password encryption? To answer these two questions, we conduct a large-scale measurement on Alexa top 50,000 websites. And for each website, we submit a fake username and password through our automatic login framework, which we will introduce later. And we collect the login requests and corresponding server IP addresses. We check the login request and the IP address. If the IP address belongs to a CDN and the login request contains plaintext password, we consider that the website exposes the password to CDN. But if we cannot find the plaintext password in the login request, then we think that the website used client-side password encryption. However, if the server IP address does not belong to a CDN, then it's probably because that the websites use the CDN bypassing to send the login request. So to finish this large-scale measurement, we need an automatic login framework. So in our work, we develop such a framework based on some heuristic rules. Please see our paper for more detail. We verify our framework on 100 websites manually, and it shows that the framework has a high accuracy with 0 false positive. The code is available at the GitHub. As a result, in the Alexa top 50,000 websites, our framework can detect the login interface of 70,000 websites. And there are 12,000 websites adopt CDN. And among those CDN-enabled websites, there are about 4,000 websites expose the password to the third-party CDNs. Therefore, we can conclude that about 33% of CDN-enabled websites expose the password to the CDNs. Then we check the distribution of websites over the CDN providers. In this figure, the x-axis is the CDN providers and the y-axis is the number of websites. And the blue bar represents the CDN-enabled websites. The red bar represents the password exposed websites. And the number above the bars means the fraction of the password exposed websites in the CDN-enabled websites. We have two observations here. The Cloudflare and Encapsula can observe a large portion of the passwords from their customers. For Encapsula, it's about 66%. It's because that the Encapsula provides a service to cache dynamic content for a short period. So we suspect that the Encapsula will cache the username and the password by default in their service. And for Cloudflare, we find that it originates from the anycast redirection used by the Cloudflare because the other CDN provider use the DNS redirection instead. We verify such a suspicion by checking the Cloudflare anycast. When the websites use the Cloudflare as a CDN to implement the anycast redirection, the website is required to transfer its DNS provider to Cloudflare. This will transfer all DNS records, including the record of login domains, such as the login.example.com, to Cloudflare. So the login domain is hosted by Cloudflare by default, and the login request is sent to Cloudflare by default. So we verify this suspicion by checking the number of Cloudflare-enabled websites using the Cloudflare DNS. Here is the statistical results. And we can find that the diagonal numbers are much larger than the other numbers. And the chi-square test also show that there is a very small p-value. So we conclude that the password exposure is highly relevant to the usage of the Cloudflare DNS and anycast. We also investigate the distribution over website categories. We divided the website into 14 categories, and the x-axis in this figure is the categories of the websites. And we can find that most retail websites expose password to CDNs. And for some websites, such as finance, travel, and health, they are usually considered to have specific protection user data, but actually they also expose users' password to CDNs. Next, we take a look on the user client-side encryption related to the ranking. In this figure, the x-axis is the ranking, the y-axis is the CDF of the passwords exposed websites. And we find that the linear CDF means that there is no bias in the ranking in our data sets. So we divided the websites into 100 ranking interval, and each interval includes 500 websites. We then calculate the percentage of password exposed website in the interval. In this figure, the x-axis is the ranking intervals, and the y-axis is the percentage of the password exposed websites. We have two observations in this figure. The first thing is that the top websites tend to encrypt the passwords, as we can find in the first few ranking intervals. And there is a high peak at the end of the intervals. It's because that in these intervals, there are a lot of the retail websites of the Tmall, such as KFC Tmall and the normal Tmall. And the Tmall is a very famous e-commercial website in China. And this website uses the client-side passwords encryption. So when your user try to log into the retail websites, it will be redirected to the Tmall websites, leading to the high peak in this interval. Overall, we find that less than 17% of websites encrypt the passwords. So based on our study, we have some suggestions. The first thing is that we need further research on solutions. The OAuth and PACKY can solve the problems, but with limitation. The OAuth will lead to single point of values, and the PACKY requires the trust on the first use. And there are also some solutions proposed by researchers, but they are not at all widely deployed in current web ecosystem yet. And the users can use two-factor authentication to protect their accounts. Websites should adopt client-side encryption to prevent the passive attacker who do not tamper with the message. As for CDN, they should involve in developing and deploying the advanced solutions. We hope our study can raise the awareness of such a password exposure vulnerability. For conclusion, we conclude that 33% of CDN-enabled website expose user password to CDNs, and less than 17% of websites adopt client-side password encryption, and Cloudflare and Encapsula observe passwords from a large percent of their customers. Finally, our automatic login framework is available at GitHub. Thank you very much, and I'm happy to take any questions.